if you want to write a program for chess, okay, so chess is nothing but a matrix, right? 8 by 8 matrix. So the chess is matrix, right? So rows and combination, right? Any certain games. And when you want to write a path finding techniques, the shortest path of a area, shortest path. For example, as we started our example as a king, if you are a king and you are in war, so you should identify a shortest path for your food supply, water supply, or a shortest path to attack other kingdom, right? So there are numerous examples. We will use data structures in the algorithm by unknowingly also. When you want to write a program for searching, we will use data structures. And when you want to compress the file, or when you want to do some operations, kind of shortest path, file processing, image processing. Definitely nowadays everyone use our cell phones, smartphones. We will use most of the time we will deal with image processing, but we are not aware of that. When you are editing an image, when you are editing a video, these are all things are basically developed on these data structures. So data structures can be an array, so an array or linked list, or any linked list, or anything. So what is the use of this data structures? Matrix. So everything is like the representation of how we will store the data and how best we will retrieve the data. Based on our requirement, we will use the best suitable thing in our programming language. So, for example, to store the bits in computers 1 and 0, what we will use? We will use basically heap memory, right? Heap memory, whatever it is. Though that is random access memory. Random access memory is nothing but an array. So we will store it and we will retrieve. So to store or retrieve, what is the complexity? It will take constant time. So when you are retrieving from RAM the data, it will take constant amount of time. So we will use data structures in many circumstances in our day-to-day life also. So we now we will learn about sorting, one of the sorting techniques. So why we use sorting techniques? Why we use sorting techniques? Because sorting is very much required. For example, government want to publish exam results. So they will publish the result in sorting order of student name, right? From A to Z. Not only exams, anyway, many places we require sorting mechanism to accomplish some complex goal. Okay, so we have multiple different types of sorting algorithms. So now what exactly we are going to discuss is insertion sort, sorting techniques basically. So this is an algorithm. This algorithm can be used for sorting some set of data. For example, I have data like 5, 2, 3, 1, or A, C, B, or some word, what, where, when. So I have 3 different types of data. For example, see, this is numeric data and this is some character, this is words. So when you want to compare 2 documents, okay, when you want to compare, for example, you created one document and other person also created same document, and you want to compare how close those documents are, whether is there any copy happened or for any reason. We can use it for any reason. So before coming to a point whether those documents are identical or different, we will, before doing that comparison technique, we will apply the sorting mechanism so that we will get easy way to understand our problem. So sorting will be useful for easy way to understand your problem, whatever problem you are going to solve. So if the numbers are in sorting order, then you can easily find out what is the pattern or what can be the approach to identify the problem. Instead of if it is random like this, then it will become difficult to understand. For example, so I have three different kinds of data set here, right? These are numbers, these are characters, and these are words. So these three things I want to make them as order, in ascending or descending order. So in this case, we can utilize one of the sorting mechanism algorithm that is called insertion sort. Insertion sorting methodology or algorithm, whatever it is. So what exactly you mean by inserting sort technique? Okay. For example, I have 5, 3, 2, 1. Okay. These are my input. Let's imagine this is my input. Okay. These are in one sum array. Okay. So array will contain list of items, right? So now I want to sort this data in a way. I want an output like 1, 2, 3, 5, ascending order. So I want an output like this from this data by using insertion sort. So what exactly we will do in insertion sort? We will follow some approach based on some key. So here we will take key index. This is key is like almost like an index. So based on some index, we will try to traverse the array and we will try to arrange them in a sorting order. So in this case, my index are 0, 1, 2, 3. Okay. So first what we will do is we will take an index of 1. So this is my key now. So now what we will do, whether this key, what is the key value here? This array of 1, what will be the array? If my array is A of key is what? 3, right? 3. So what we will do? Now we will compare this key value with lower index. So for example J, this is I, this is J equals to I minus 1. So what will be my J equals to I minus 1? My key is, I is key, so 1 minus 1, 0. So now what I will do, we will compare this A of I and A of J. So now what is my A of I? A of I is 3. So what is my A of J? J is 0. So A of J is 5. Now I will compare these two things. Which one is greater? If 5 is greater than 3, then I will do a swap. Otherwise I won't do. So in this case, 5 is greater than 3. So what I will do, I will swap these two numbers. Okay, 5. Now after swapping this, because 3 is lesser than 5, so I need to do a swap. Okay, so my output after swapping 5, 3, 5, 2, 1. This is my output now. So now what I will do, I will increment I value to the next index. Okay, now my I value will be initially 1, now it will become 2. I value is 2. Now so when I is 2, then what will be the j? J equals to I minus 1, right? So my j value will be 1. Okay, so these are my 0, 1, 2, 3. So what exactly we will do? Now we will apply the same rule. A of I and A of j. Right? What is my A of I? A of I is what? 2. What is A of I to? 2. And what is my A of j? A of 1. A of 1. What is this? 5. So again 2 is lesser than 5. So again we will do the swap. Right? This is first swap, first comparison, second comparison, now third comparison. So second comparison. Second comparison, what will be the output for me now? 3, 2, 5, 1. Right? So now again I will increment the I value. So now I will become 3 and j will become 2. Right? So now what we will do? 0, 1, 2, 3. Right? So what is my 3? A of 3 is 1 and A of j, basically j equals to I minus 1, right? So j will be 2. So j will be 1 and 5 we will compare. 1 and 5 we will compare. So 5 is greater than 1. So we need to do a swap. So what we will get? 3, 2, 1, 5. Okay. Now we reach at the end of the array index, right? So again we need to do the perform same operations. Again we need to do 3 to we need to compare, and we will if it is if comparison is satisfied, then we will swap it. Otherwise we will proceed with that. So this is what exactly insertion sort will do. So it will compare a key value and -1. So if it is lesser than, then we will do a swap. Otherwise we will proceed for, we will increment the I value to next step. Okay. So now what we will do? Now what we will do is, we will try to implement a random way of try to solve this problem. Our goal is to sort a given data. So why can't we blindly we will go with some for loop, for example, some for loop. So what we will do is, whether it is wrong or right, we will come to know later point of time. But initially I want you to try from your end. For example, I equals to 0, I is lesser than n, I plus plus. Okay. Okay. So what exactly we are doing? So I, let's key, right? I equals to 1. Let's make it as key. I equals to 1. So j equals to I minus 1. Okay. So now what we will do, if this is my array 5, 3, 2, 1, for example. So if A of I is lesser than A of j, then do a swap. Take temporary variable A of already, okay. Take temporary variable and swap it. Do a swap. Okay. Let's imagine this is we've written, for example. So now we will try to traverse this program by using this data. Whether we achieve our sorting technique or not, can we solve the sorting problem or not, we will see. So what is my I? I is 1. So what will be my j? 0, I minus 1, right? So what exactly I am doing? A of I, what is 0, 1, 2, 3 index, right? So this can be by, if this is C code, index will be 0. In some other program languages, this index will start from 1. Okay. For now, just imagine index started from 0. So my j equals to 0, I equals to 1. Now what we are doing? We are comparing A of I a of I, that is 3, is 3 is lesser than a of j. True, right? So what we will do? We will do a swap. So let's imagine we done the swap. 3, 5, 2, 1. Now what we will do? Again loop will execute. Now I becomes 2. Now j becomes 1. Okay. So now we will compare. What is a of I? A of 2 here 0, 1, 2, 3. So what is my a of 2? A of 2 is 2. Is 2 lesser than a of j? A of j is a of 1. Right. 2 is lesser than 5. So what exactly we will do? Again we will do a swap. 3, 2, 5, 1. Right. So now again loop comes to here. Now I became 3, j became 2. So 0, 1, 2, 3. So a of 3 is 1. A of 3 is 1. 1 is lesser than a of j. A of j is 2. Right? This is true. So we will do a swap. 3, 2, 1, 5. Okay? So after that what will happen? We reach the end of the array n number. So we are done with our program, this program. So we are left with 3, 2, 1, 5. But this is not in a sorting order. So how can we solve this? Let's imagine. For example, if I add another for loop on top of this. Okay. Some x equals to 0, x is lesser than n, x plus plus. Okay. Just imagine if someone added another for loop, can this will be solved or not? We will see. So when x is 0, this entire loop will execute and I got this output. Right? So when x is 0, I done this loop, this is inner loop, right? So when x is 0, we will traverse it one time. So now what will happen after this result? End of the result, x will be incremented to 1. Okay. So when x is 0, this is my output. When x is 0, what is my output? 3, 2, 1, 5. Right? So now x will be incremented because my inner loop logic is completed. So we will go to x. So x will become now x equals to 1. So what exactly we will do? Again we will need to traverse from I equals to 1 to this one. So 0, 1, 2, 3. Let's do this. So what will happen? My I is 1, j is 0. Again we are looping through. So what exactly we will do? Now x equals to 1, right? So what is my a of 1? A of 1 is 2. Is 2 is lesser than a of j. What is my a of j? 3. Is 2 is lesser than 3? Right. So what we will do? We will swap this. So my output will be 2, 3, 1, 5. Right. So now I will become 2. So I will become 2. J will become 1. So what will be my 0, 1, 2, 3. So what is a of 2? 1. Is 1 is lesser than 3. Right? A of 1. A of I means a of 2 is 1. A of j, that is 1. A of j is 3. So is 1 is lesser than 3? True. So what we will do? Again we will swap these two things. Let's imagine 2, 1, 3, 5. Okay. Now I will become 3. J will become 2. So now the index are 0, 1, 2, 3. Okay. Now what is my 3? A of 3 is 5. Is 5 is lesser than 2? Wrong. So there is no need of swap. So we reached end of the array. So what will happen again? Now x will become 2. So again we will repeat this same logic. Right? So this is my final output of x when x is 1. Now again we will do the loop. So again it will initialize to 1, j will be 0. So what is my a of 1? 1 is lesser than 2. True, right? So what exactly we will do? We will swap it. So 1, 2, 3, 5, right? This is my output. So now index are 0, 1, 2, 3. So now I will become 2, j will become 1. So what is a of 2? 1. A of 2 is 3. Is 3 is lesser than 2? No. So we won't do any swapping. Now it will become 3. It will become 2. So what is my a of 3? A of 3 is 5. Is 5 is lesser than 3? No. So I won't do anything. Right? Now we reach at the end of the thing. Again now x will become 3. So again we will repeat the same thing. But if you observe, already this data is in sorting order. Okay? So if you observe, by using this code also, we are able to sort this A data, a given array, into 1, 2, 3, 4, 5. Right? So this code also will be useful for sorting. So what is the problem with this piece of code? So we can write n number of ways to solve one problem, but what is the problem with this piece of code? Let's see. What exactly we done is, if you observe, this for loop, how much time it will take? N number of times, right? The complexity of this for loop is n number of times. So this for loop, another n, right? So what will be my complexity of this program? Order of big O of n square. Okay, this is fine. This is fine. But order of big O of n square, this is fine when the given array is not in sorting order. Okay, let's imagine if this is kind of my A, what exactly we done previously? Even though my array got sorted already, but again I am trying to loop through my upper loop, right? So for example, this is fine when your given input data is not in sorting order way already. But let's imagine, for example, instead of like this, if I given A equals to 1, 2, 3, 5. Okay, if this, instead of this value, if I given this value to this code, what will happen actually? See, what will happen, because this for loop will execute n times, this for loop will execute n times, even though my given input is already in sorting order. So this is best case actually, right? This is best case data, because I am lucky to get this type of data that is already in sorting order. So nothing no need to do anything. But because of my this programming, what exactly happening? Even though my given data is in sorting order, I am doing inner loop executing n times, outer loop n times. So even for best case scenario also, my above code leading to complexity of giving order of n square. So we can reduce this. Order of n square, big O of n square is fine for when the given data is not in already sorted order. But if my given data is in already sorting order, so I should be able to reduce the complexity, right? I should be able to reduce the complexity by using some algorithm, some technique. So we will try to find a way, try to find a program algorithm that will lead us to, when your data is input when your input data is already in sorting order, instead of order of n square, big O of n square, can we reduce the complexity? If my given input is not in sorting order, already not in sorting order, then it is fine. I will take this amount of time. But if it is already in sorting order, I don't want to spend this much time, this much complexity of my algorithm. So we will write another algorithm so that it will behave based on the input. So if my input is already in sorting order, then there is no need of order of big O of n square complexity. I want to reduce some little bit, right? So now we will see that algorithm. Now with our previous program, we faced the issue when my input data is already in sorting order. Even though I am spending a lot of time, my complexity became order of big O of n square. But here we have another program. This is insertion sort algorithm basically. The logic is this pseudocode is insertion sort algorithm. So what exactly we are doing? Here also we are maintaining one key. This is key is x equals to a of I. Okay. I is we initiated with 1. So this is same piece of code, but instead of 2 for loops, we come up with in for loop we have another while loop. Okay, that will take care of the logic basically. Okay, so what exactly we are doing? This is a piece of pseudo code for insertion sort algorithm. What exactly we are doing? For I equals to 1 to n, n is the size of your array, size of your data. So for I equals to 1 to n, okay, what exactly we are doing? First initially I am maintaining a key that is x, in this case x equals to a of I. That is what this key. So again we know j equals to I minus 1. So what will be here? I value will be 1 if j value will be 0 because I minus 1. So after that this is the key point. So what exactly we are doing here? So we are checking two conditions here. This is one condition and this is second condition. What we are verifying here, whether j is greater than or equals to 0. That means whether if my array started with index 0, whether my j is greater than or equals to 0 or not. So that means whether I am at starting point or not. Okay. Then after that what I am doing? We are comparing ij values basically. This key value and j value. If j is greater than x, that means 0 index is greater than 1 index, then we will do a swap. Okay. This finally we kept this I value as a temporary variable. So that temporary variable we will assign it to here. So now what exactly we will do is we will try to execute this program on given already sorting order. For example, if my A is 1, 3, 5, okay, just imagine this is my array given data 1, 3, 5. If you observe, this is already in sorting order. So how exactly my program will behave for this? So we will try to traverse through this program. So initially what my I is 1. So what is my x? What is my x? X is a of I. So 0, 1, 2 index. So what is my a of 1? 1 is 3. So j. What is my j? J equals to I minus 1. That is 0. 1 minus 1, 0. So now we got while loop. So while j is greater than or equals to 0. So this condition satisfied because 0 is greater than or equals to 0. Or you can write it like minus 1 also. If j is greater than minus 1 also, this will be fine. So if my j is greater than minus 1, right? So and a of j, what is my a of j? A of j is 1 is greater than, what is my x? X is 3. Is 1 is greater than 3? Is 1 is greater than 3? False. So this while condition won't execute at all in first when I is 1. So what will happen? This statement not executed. Okay. Now this statement will execute. So a of j plus 1. What is my j? So a of j plus 1. J is 0 plus 1 equals to what is my x? 3. So we are just keeping the value same as. Okay. Why we kept this value in x? Because if some reason if this condition satisfies, then we are using like a temporary variable for swapping purpose. So in this case already 3 is that, again we will keep 3 in that place only because there is no need of swapping. Now what will happen? My while loop ended and this statement got executed, and now my I value increments. Now my I value will be 2, right? So if my I value is 2, what is my x value? X equals to a of I. A of what is my a of 2 is 5. What will be my j? J equals to I minus 1. That is 2 minus 1. 1. Okay. Now we comes to this point. While j is greater than minus 1. Right. 1 is greater than minus 1. Right. So and a of j. What is my a of j? A of 1. What is my a of 1? 3. Is 3 is greater than x. What is my x? 5. So is 3 is greater than 5? It leads to false. So that means this time also we are not executing this while loop, right? This time also we are not executing this while loop, and we will keep the same value here. So now this statement got executed. Now I will move to next value. What is my will be I? My 3. So what is my length of this? N. For example 3. Let's imagine 3 or 2. Okay, based on your length. If it is 3, what is my x? There is no x because my length of my this is 2 here, right? Right? So there is no need to traverse now. Now if you observe carefully, you can add a number of another items also. You can repeat this procedure, execute this procedure, but if you clearly observe what actually happened compared to previous algorithm, previous program. So when my input is in already sorting order, what actually happened? Only if you observe, this for loop got executed. Same as, so this for loop will execute up to what times? N times, right? N times. But in this case, this while never got executed. That means what? These statements under this while loop never got executed. There is no chance for them to execute. So they never touched, our compiler never touched, executed these two statements because we've written the program in such a way, because if the given data is already in sorting order, we come up with some good idea so that this while loop there is no need to execute if my given data is already sorting order. That means what? This is best case scenario, right? You are very lucky to provided by a already sorting data. So then what will be my complexity of this program? If you observe, what is the complexity of this like piece of code? Order of 1, constant, right? So to execute this statement, it will take always 1, constant 1. This will also take 1 time. Because this while loop never executed, so we won't consider it. Again, this statement will take order of 1 time. So, and this for loop will execute n number of time. So what will be my complexity of this program for best case scenario? For best case scenario, my complexity is order of n. So, but previously we are ended up with order of big O of n square because of some flaw in our programming language. Not language, programming, what exactly we written, that has some, our piece of code has some problems. So that produce order of big O of n square, but this logic produce we are end up with order of n instead of order of n square. So this is insertion sort. So basically, when we need to use insertion sort, we should know basically. So if my given data, mostly if it is in already some sorting way, then we will go for this insertion sort. If my given data is very much randomized, it is not in any way the numbers or data, words or characters, whatever it may be, if those are in unordered, more 80% or some more percentage is not ordered, not already ordered, that means what I want to convey is, if your input data in some way already in sorting order, apart from some little bit movements required, then go for insertion sort. But if your data requires lot of swappings, then insertion sort is not suitable basically. So this is called insertion sort. Try from your end so that it will be good. Instead of writing this piece of code, you try from your end how can you sort a given data. Okay, how can you sort some data based on whatever you feel. Just write your for loops or while loops, whatever it is, but don't straight away write this program or copy this program. Try to do yourself to find a solution and try to execute that for this input already in sorting order, and see whether for this input whatever you program written, that program leading to order of n, or if it is taking more amount of time, that means whatever piece of code you've written that has some issues. And try to observe this piece of code later point of